So in order to, so these brackets here, so these brackets right here are represented by a less than or equal, you know. So the brackets in what I'm trying to say here, brackets mean inclusion, that is less than or equal, even including the elements in the endpoint of the interval, right? And for the set builder notation, all we do is simply copy and paste this in a set builder notation. What does that mean? The way we read this is x such that x is greater than or equal to a and less than or equal to b. We're going to get into reading these sentences more in depth later, right? Don't worry if right now looks like a lot of information. We'll get there. And again, it's called a closed interval. How do we graph this? Well, so a closed interval, let's draw a number line. And just put random numbers A and B. I don't know, they could be -5 to 7, maybe 0 to 5, maybe -5 million to pi, for your favorite numbers. Doesn't matter. So what we're trying to say here is, well, this is the same as saying, well, I'm going to represent this A with a solid bubble here, with a solid circle. You will see the difference in the next example between the solid and the open circle, all right? And what we're going to do here is shade all the numbers in between. All right, I'm going to shade all the numbers in between. So that's what a closed interval looks like. That is all the numbers between A and B. But the fact that these points right here are fully solid, that means we also include the the endpoints. All right. A real life example, to go to a club. All right, to go to a club, you have to be 21 years old or older, right? So that means if we represent that with an inequality, well, you mean if H is represented by X, well, so to get into a club, X, your age has to be greater than or equal to 21, all right? So the inequality symbol matters versus X greater than 21, right? No, that, or even less than 21. So the equality symbol actually matters. So if the very second you turn 21, you're good to get into the club, right? You don't have to wait 5 minutes later, or no, actually the very second you turn 21. So that's the difference between X including the 21 or the endpoint versus not including it, all right? Okay, what's the difference for the second interval? Well, notice we have a parenthesis and we have a bracket here. So there's going to be a different representation for each. Well, so let me make this a little smaller again. And I'm going to use a different color. I'm going to use green for the parentheses and yellow still for the bracket. All right? So the bracket, again, includes the equal. However, the parentheses, it's just less than. It does the parentheses. It's left open. It's half open. Why is it half open? Because it's open on one side, but it's closed on the other side. Or another way to call this kind of interval, not just half open, can be also called half closed, depending on what you prefer. Either way is fine. But I just typed one version of it. Either way is fine. All right. Now the way we are going to represent, and in this case I will write the numbers A and B. So yes, right now it looks very symbolic. Are we going to see this with numbers? Yes, the next page is full of examples with numbers to make more sense about it. So that's A and B, and well, In the previous example, in the previous interval, the fully closed interval, we represented the endpoint as a full circle, as a solid circle. However, the open one is represented with an open circle. All right? Okay, what am I going to do next? Well, I'm going to draw a number line, and in this case, again, I'm going to shade all the numbers. Notice in my shading here, I'm being careful not to touch anything inside of the hole right here, right? Because we're not supposed to include the value here, but we do include it for the upper endpoint. All right? The next kind of interval, well, it's going to be exactly very similar to the previous one, just to reverse. We're going to have it closed on the lower endpoint and open on the higher endpoint. And so the way to go about drawing this graph right here is by, well, let me plug my laptop, it's dying. All right. So it's full on the lower endpoint and empty on the higher endpoint, right? A and B. And let me highlight all these values, everything in between, but in this case without touching anything on wall. I've already got a couple of pixels inside that open hole. Well, but as long as we have that open hole representing the exclusion of that endpoint, in this case the upper endpoint. So what do we have so far? Fully closed, half open or half closed, half open, half closed, fully open. Fully open in this case. Open circles for both. They both represent A and B. And again, let's shade all this. Again, being careful not to touch anything on the endpoints, right? All right, the next few ones involve this infinity symbol. What do they represent? Well, it's close on the lower endpoint, even though this infinity means goes on forever, and it has parentheses. By the way, infinity always has parentheses. Never write the infinity with a bracket. Why is that? What would that be incorrect to have the infinity symbol with a parenthesis? Well, the reason to that is because infinity is not a number. Infinity is just an idea to describe something that never ends at all, just gets bigger and bigger and bigger. So in a way, we leave it open to our interpretation of how big we want it to be. All right? So that's why we have parentheses about it. And also, if we say infinity parentheses, that means infinity. It's an actual number, which is not. That's why we leave it open. All right. So how do we represent this one? Well, I'm just going to go with letter A, which is going to be a solid bubble. That's because we have bracket. But in this case, check this out. Here, we're not going to have a limit. We're not going to have an upper bound B. It's just going to go all the way forever. Like this. All right? And of course, the arrow indicates that it's going all the way to infinity. All right? We're going to use that to indicate such a thing. Similarly, the difference between the next one and the previous one is the bracket and the parentheses. So instead of having a full circle, we're going to have an open circle. Open circle, that's A. And again, Whoops. Let me shade. And again, we can stop shading at the tip of the arrow. The arrow indicates that it is going to go forever. So those are the two open and closed intervals that involve an infinity. There's another couple of them, and of course they're inequality, the corresponding inequality versions of them. In this case, there's no bound towards the left, but there's an upper bound towards the right. How do we represent? Well, bracket means solid. But in this case, without a bound, but towards the left. All right? Similarly, that upper bound may not be included, may be excluded from a given domain. And yeah, I know we're going like one at a time. Maybe some, if not all of them, already make sense. But trust me, there's a big purpose for this. You'll see. So okay, I wanted blue. That's open, and that's A, or rather, oh, this is B, rather, right? B. And let's go about shading it in green. By the way, guys, I use a lot of colors, so if it works for you, feel free to also bring your highlighters or markers, whatever works for you, so you can also follow along with what I do here. The last one, negative infinity to positive infinity. This is in fact simply all real numbers. That's a fancy symbol for all to represent all the real numbers. And what we do here is just draw a number line without an A, without a B, because the fact that we're talking about all the real numbers, there's no lower bound, there's no upper bound, it's just all real numbers. So let's see. Shade the entire domain. We will connect these ideas with different kinds of functions later, like radical functions, polynomial functions, rational functions, and their domains. And as far as how do we represent their restrictions, some of them have restrictions, red flags, if you will. Some of them do not. You will see about it. All right? Okay, so how about we look at the numerical example so we can see what these intervals mean. Okay, so the interval bracket -2, 4 bracket represents the set of numbers between -2 and 4. Now, in this case, the interval includes both endpoints. All right, includes both endpoints because we have the brackets here. All right, and this interval is represented by the inequality. So check this out. This is what we're going to do. We're going to write the letter X greater than or equal, less than or equal, and that's going to be -2 and 4. All right. Because this interval is describing all the numbers that are between -2 and +4, including the endpoints -2 and +4. This inequality is telling us all the x values that are greater than or equal to 2 and less than or equal to 4, which is a slightly different way to say all the numbers in between -2 and +4 inclusive. All right? What about letter B? The interval -5, 7 represents the set of numbers between -5, we'll list the lower endpoint first, and 7. Now, here is the thing. The interval excludes the number -5 and includes the number 7. How come? Because, well, what do we have? Parentheses means we exclude the lower endpoint, and then bracket, we include the upper endpoint. All right? So far so good. Is everything making sense so far? All right, let's see. Let's look at the next one. The interval negative infinity to positive 6 with a bracket represents the set of numbers that are less than, or I needed more space, less than or equal than 6. All right? Yes.
It's the inequality.
Oh yeah, the inequality for b. Thank you. For b, okay, again, negative 5, x, 7. Well, because the negative 5 has parentheses, we only use the less than symbol because the upper endpoint has brackets, is less than or equal. All right. So you can think of the brackets to go with the equal and the parentheses to go without the equal. That's another way to think of those. And then the interval includes the number 6. And it is represented by the inequality. Okay. So here, since we have an upper bound, that is, we have a maximum value of 6. That is, we're looking at all of the numbers that are, okay, the question is, to the right or to the left of 6? Right. To the right or to the left? That's you? No worries. Would it be all the numbers to the right or to the left of 6? To the left, because they're going towards the negative side. Now, this inequality is represented. Just write the letter x, the number 6, and use an inequality symbol that represents some displacement towards the left. In this case, less than, but because it's a bracket, it's less than or equal. All right? And the last example, at least for these 4, we have the interval 3, infinity, represents the set of numbers that are just greater than. Now, these are just greater than. Notice I didn't say greater than or equal. How do we know that? That's because, well, we have parentheses. That parentheses gives us a sense of exclusion for that lower value of 3. So we're just looking at the numbers that are greater than 3, not greater than or equal. So greater than 3. All right? The interval excludes, this time, excludes the number 3. All right? And it's represented by the inequality. Again, just write the letter x, write the number 3. Now, let's think about this interval. What is it doing? So is that interval describing the numbers to the left of 3 or to the right of 3? So we need an inequality symbol that gives us a sense of direction towards the right. It could be either greater than or equal. Which one would it be this time? Just greater than, right? Because it's excluding the upper endpoint of 3, the lower endpoint rather of 3, not the upper, the lower. And that's how we represent this one. All right? Let's see. So another example. So now this is what we're going to do. We're going to go back and forth between interval notation and inequality notation. So let me do a couple for you, and then I'll let you work on some of them on your own. Okay, so for example, every time you want to go from interval notation, by the way, careful. This one right here, that -4, 0, it's very oftentimes mistaken as an order pair because that's how we represent order pairs, right? The x equals to -4 and y equals to 0. You need to be very careful All you need to do is just change the chip in your head, like, oh, we're talking about intervals, we're not talking about points. If we were talking about points or function values, well, x would be -4, y equals to 0. But no, in this case, we are describing an interval of numbers or a range of numbers. That's all we're doing. And in this case, excluding the -4 and also excluding the 0. What do we do in this case? Well, simply put the x in the middle. X, -4, leave space for inequality symbols. And what we're going to do is to choose the right inequality symbol. So it's between either less than or less than or equal. Which ones are the correct this time?
Less than.
Both, for both of them, right? Because both have parentheses. Again, the parentheses is related to the lack of the equality. The brackets is related with the presence of the equality. So that's how we do in this case. Let me do one inequality, change the inequality to interval. This one is usually really easy. All you have to do is get rid of the x and the inequality symbols. Just write down -4, comma 10, and just choose the correct inclusion exclusion symbol. So because in this case we have, or rather we don't have the equal underneath the inequality symbol, but would that correspond to bracket or parentheses?
Parentheses.
For both, right? That's all we do. All right. Okay, so the interval letter B. Okay, any inputs? What you got? Yes.
2 less than or equal to x less than or equal to 9.
2 less than or equal to x. All right. Less than or equal. Sounds good. Okay, anybody else for letter C? What you got? Yes.
1/2 less than x less than but equal to 3.
Equal. Right. One has parentheses, one has brackets. There has to be some way to distinguish between the two. All right. Then -infinity to 3. Someone else? Yes.
X is less than 3.
X less than 3. All right. I agree with the less than 3. Well, notice that 3 it has bracket. That means that 3 is included in it. So maybe if we change this to less than or equal, right? What about letter E? Someone else?
X is greater than 2.
X is greater than 2. That's right. X greater than 2. All right. That's all about parentheses, excluding the endpoint. That's correct. And well, letter F, we already got it. Now let's go back to interval, from inequality to interval. That is, what we got for this one? Someone else? What do you got here?
Parentheses 0, 4 bracket.
4 bracket, that's correct. Letter H. Anybody else? Don't be shy, that's fine. Yes?
H. Bracket -5, comma 5 parentheses.
That's correct. What about letter I? Someone else? We got for letter I. Yeah, you. No, you. Yeah.
3, comma, infinite, comma.
So parentheses 3, comma, infinity, comma. All right. What about letter J?
Parenthesis minus infinity, comma, bracket.
And last but not least, how about -infinity, -1/4 with bracket, right? Because we have the less than or equal, right? Let's see.